All right, everyone, thank you so much for joining the webinar. My name is Katie Kaluzny. I'm with the Illinois Green Alliance, and we're very excited to be kicking off the All-Electric Home New Construction 101, Envelope, Mechanical, Solar, and Incentives. And we're really excited to be hosting this session in partnership with the ComEd Energy Efficiency Program. I'm going to start with just a couple of logistics before we hand it over to our panelists to say a few words. So let me just get started. You've all been muted, as you probably realize, but please type any questions that you have into the chat or the Q&A, and at the end of the discussion, we'll have time to address the Q&A after all of the presenters have finished. I also want to let you know that we're recording today's session, and we'll be sharing the recording in a follow-up email. We'll also share a combined PDF of the presentation so you can look a little bit closer to some of the resources and links and information that's shared today. So please, again, put questions in the chat and we will get to you as soon as we can at the end. A little bit more about the Illinois Green Alliance before we get started. We are a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. We recently launched a 5-year strategic plan that pushes the green building industry on the path to net zero. And so we are going to achieve this work through educational events like this one today, engaging with communities and partner organizations across Illinois, and advocating for new policies and legislation. Our members can view our recorded webinars of past education in our on-demand library, where this one will be again after today. And then our next 2 webinars that we have upcoming are on March 3rd and March 11th. On March 3rd, we have our second installment of our new Building Decarbonization Tech Series. And on March 11th, we have our Well Commercial Office virtual tour with ASID. So check out Illinois Green's event calendar and our Connect and Learn page for more information, and sign up for our newsletter. We send out events every Tuesday with all the things that are upcoming from us and from our partners. And I do want to thank our partners for the webinar today. The Energy and Environment Building Alliance, the Northern Illinois Home Builders Association, the Southwest Suburban Home Builders Association, the Home Builders Association of Greater Chicago, and the American Institute of Architects Chicago. So we really thank you for all of your partnership and getting the word out about this great presentation today. And now I'd like to introduce our speakers. We have a great panel for you today. I'm going to introduce all of them up front, and then they're going to just go through the flow between all of their presentations and introduce each other when they get to their section. So first we have Kellen McSweeney. Kellen is a program manager with Slipstream and is responsible for program operations and management that support their mission and program work. She leads operations for ComEd's commercial, industrial, and public sector new construction program and manages the implementation of ComEd's Electric Homes new construction program offering. Next, we have Lindsey Elton. Lindsey is certified in advanced building science and building diagnostic testing. Her company EcoAchievers helps teams throughout the country to construct high-performance multifamily, single-family, and mixed-use buildings that meet everything from NGBS, I think that's the National Green Building Standard, to LEED, Energy Star, and Passive House standards. She currently volunteers as Vice President of Passive House Alliance Chicago and frequently speaks on topics related to building science and green building certifications. We also have Mike Schaefer. Mike is the Chicago Regional Sales Manager for Mitsubishi Electric, Trane, HVAC US. Mike has been in the HVAC industry since 2005, where he has worked on all levels, including contracting, distribution, and manufacturing. Mike joined Mitsubishi Electric in 2014 and was most recently part of Mitsubishi's performance construction team, which is focused on providing healthy, efficient, and reliable mechanical solutions to high-performance building market. And finally, we have Lisa Albrecht. Lisa is the owner of Albrecht Solar, a residential and small commercial solar developer, and has worked in the Illinois solar market since 2007. As a board member for the Illinois Solar Energy Association, she organized the Illinois Solar Tour for 5 years and served as the policy chair for 7 years, focusing on the passage of the state renewable energy credit program and advanced permitting, net metering, and interconnection policies. She frequently speaks in the public on solar and climate issues and volunteers in a number of school climate and school education programs. All of these panelists today are awesome people that I'm so excited to introduce them to you all today to share a little bit more about what they know on this topic. I'm going to turn it over to Kellen McSweeney to kick us off from the ComEd New Construction Program.
Thanks, Katie, and thanks everyone for joining us this afternoon. So as Katie mentioned, my name is Kellen McSweeney, and I work with ComEd's Electric Homes New Construction offering, which is part of ComEd's Energy Efficiency Program. And if you're unfamiliar with the program, so ComEd has energy efficiency programs and offerings that really encompass opportunities for all of their customers, whether small customers or large customers, or maybe there's projects in rural Illinois or downtown Chicago. There are really opportunities for everyone out there, homeowners looking for rebates on appliances, incentives for big manufacturing facilities. I really urge you to check out ComEd's website and find out if there is an opportunity for you to take advantage of as well. Next slide, please. So we launched the Electric Homes New Construction Program in 2020 to help builders achieve high performance all electric homes. And the offering is for both new construction or major renovation. And this slide really outlines the holistic package of energy efficiency measures required. And if for meeting these requirements, each home is eligible to receive an incentive of $2,000. So we start by focusing on a tight envelope and then move into high efficiency heat pumps and high efficient heat pump water heaters. And there we're really talking about Energy Star appliances, efficient plumbing fixtures, LED lighting, and then also smart thermostats. So this is just really high level, but you can find a lot more detail and information about these requirements on ComEd's website, where you can find the different program collateral and just digging into what these requirements are and what they entail. So feel free to check that out as well. I will have a link at the end of my slides. Next slide. So one of the most exciting aspects about all electric homes is the opportunity to offset energy use with renewables. And although these are not requirements for the program, we do highly recommend them. And just that ability to offset energy costs is such a benefit in the long run. And there have been a lot of advancements in heat pumps and solar and electric vehicles, and these really present new opportunities for both builders and homeowners. And so ComEd is really interested in supporting this big picture approach to high performance homes. And there's a handful of resources that you can find on the website as well. And I've listed a handful of resources, and I think, Ashley, if you click space, they might pop up. There they are. So there's some resources there if you're interested in solar or electric vehicles, also load management in your homes. So definitely check those out as well. Next slide. So as I mentioned, 2020 was the first year of the pilot, and we had a soft rollout with about a dozen participants. And we saw a variety of home types, home locations, and different price points as well. So you can see on this map, we really had projects all over the place: rural, urban, suburban areas of Northern Illinois. Next slide. And here are photos of the 2020 participating homes. So you can see the variety of mix in single family homes, townhomes, all the way up to 3 flats that we had participate last year. And we also saw both speculative and custom builds. So a really big variety of the types of homes that could go all electric. And most importantly, I really want to highlight that we worked with fantastic builders in 2020 who are really excited about their innovative solutions and what they're doing for these homes. And so if you're interested in speaking to past participants, our builders are happy to connect and to share their stories and share their solutions. So definitely reach out and we can connect you to those folks to learn more. Next slide, please. So I'm going to really briefly go into some of the requirements in more detail, but I won't go into much because the other speakers are going to go into much more detail than I am here. So I mentioned we start with air tightness, and this is really a huge opportunity for energy savings and increased comfort. And there's a variety of ways for how projects have accomplished this. I'm sure Lindsey will get into that in much more detail here shortly, but here's just some of the examples of what we saw. So there's blue mesh over on the left. In the middle, you can see zip wall, and all the way on the right, you can see spray foam. So I just want to emphasize that there are a variety of ways to go about air tightness, and you can really figure out which way works best for your particular project. In all of the cases that we saw in 2020, hitting that 2.5 ACH requirement was totally achievable, and we even saw projects that got down to the low ones. So just want you to know there's opportunity for fitting the needs of your home and to both meet and exceed these efficient requirements. Next slide, please. So then for mechanicals, we really started to see a formula in the 2020 participating homes. And it all starts with this outdoor unit here on the left, which if you haven't seen one before, that is your air source heat pump. And then from there, we saw either an air handler unit, which looks really similar to your typical forced air home on the top in the middle, or a mini split like this one on the bottom in the middle. But for many of the projects, they used a combination of both the air handling units and the mini splits to allow for that flexibility to solve the particular zoning needs of each individual home and project. And I know Mike from Mitsubishi is going to dig a lot more into this, so I'll let him get into the details. But the other thing I wanted to just mention is this thing on the right, which is the heat pump water heater. And it looks pretty much like a typical water heating tank, though it of course runs on electricity. So overall, these technologies are not that foreign from what you're typically used to seeing. And the tech has gotten significantly more advanced over the years to work even in our colder climates like here in Illinois. Next slide, please. So I'm just going to run through a few other configurations that we saw in the different homes, and you'll start to kind of notice the pattern I mentioned as well. So this is a single family home, and you can see it has that outdoor unit there on the left. And then on the inside, it had the air handler unit and the mini split, similar to the photos I showed above. And then the heat pump water heater. Next slide. And then in this project, again, it starts with that air source heat pump on the outside, and it's connected to two different air handling units on the inside. And then they also had a slightly different approach to water heating and used an outdoor unit split system water heater. So again, it changed it up a little bit, but following the same general formula. And then next slide. So here's the last example I'll show. It's from a 3-flat, which came into the program. And so they had 3 outdoor units and then 3 handlers on the inside, air handlers on the inside. And then they were able to suit their water heating needs with just the 2 heat pump water heaters. So as you can see, there's really a lot of flexibility within the general formula we saw to solve the space condition and the water heating needs for different types of homes. Next slide. So I want to wrap up by just sharing some of the resources that are available on ComEd's website. The first is this residential service provider list. So if you are a builder looking for HVAC contractors, definitely check out this list. You can even search for contractors that work specifically on air source heat pumps. Next slide. So Lisa is going to be getting into the context for solar in Illinois here shortly. But if you want to check out these resources on ComEd's website, you'll be able to understand potential rebates and just solar potential for your site as well. Next slide. And then lastly, I just wanted to highlight these resources on ComEd's website for electric vehicle charging, where you can learn about different types of chargers that you can install in your home. Next slide. So that is it for me. If you do have any questions or you're interested in learning more about this program, please don't hesitate to reach out to either myself or my colleague. I've listed our contact information there. And again, you can find all of this information and a lot more details on the website link that I've posted above. So thank you so much for being here this afternoon. And now I'm going to send it over to Lindsey from EcoAchievers.
Thank you, Kellen, and good morning or good afternoon, everyone. My name is Lindsey Elton. As Katie mentioned at the beginning, I run a company called EcoAchievers. We're a dedicated group of building scientists that work with single-family homes, multifamily, commercial buildings as well. We do all of the green building certifications, and funny, some of the project photos that Kellen had up there, those were our projects, and some of the slides that you'll see of mine are of those project details as well. So next slide. And I just wanted to reiterate and just frame this part of the conversation in the context that you can build it tight. It's just a matter of taking the time to plan it and communicate it, and it is feasible, and we'll make it happen. Next slide. So as part of that, and just keeping this kind of strategic and how to think about it, just with any plan or with any project, we need to plan how we're going to make the air sealing details and the air barrier details happen and make them effective. Next slide. So one thing to keep in mind, and when we take a look at single family homes or multifamily projects, the buildings work as a system. So in the house, different trades and different aspects are going to affect the overall performance. There's a number of areas, and this very much happens with air leakage and the envelope. There are a number of areas that are typical problematic areas for air sealing. In a nutshell, those are the transitions, the envelope transitions. So your wall to ceiling, your floor to wall, crawl spaces, attics, things like that. Any of your MEP, plumbing, mechanical, electrical penetrations, and as well as your media penetrations as well. So these two items, there's a lot of great resources out there where you can find more information. The Building America website, DOE, EPA, Building Science Corporation. There's an app called Construction Instruction that has videos that you can use for people or contractors that might not all speak English too. So there's a lot out there that will help you be successful. And I would say one of the keys of being successful is to talk about those details and make sure that the details are on plans so that everybody knows what's expected. Next. And then once you have those areas discussed and talked about, it's what materials are you going to use? I know today that we're talking specifically about single family homes, which is which is on the left, but the same products can be used. You saw the Henry Blueskin in one of Kellen's slides. There's the Prosoco, Tremco. So these are all fluid applied, or you've got fluid applied air barriers, or the panel stick and peel air barriers. So there's a variety of different types, whatever fits your project needs. I would also say whatever fits your project's climate type. Some of these materials have a hard time working properly in the colder climates. So just keep that in mind as you're speccing and as your contractors are applying them. Next slide, please. This is just, again, as you're planning the various aspects and areas, you've got tapes, you have fluid applied, you've got caulks, you've got sealants. One thing to keep in mind is the logistics of things. So as trades are doing their activities, making sure that when you have certain assemblies already in place, you don't have a trade that comes in afterwards and in doing their work disrupts the air sealing that you've done or disrupts some of the air barrier. Next slide. Oh, this is one of the air sealants that is not approved that we saw on site. So just a little humor today. Okay, next slide. And then the last piece of this is when you're talking about materials, making sure that you're selecting the right ones that go in the proper locations. So you're not using a caulk that needs to fill a 1-inch gap. You're using the proper expanding foams, or you're using tape. So it's just thinking through the smaller details, because air will choose the path of least resistance, and you want to make sure that you've got that done correctly. Next slide. And then the final piece of the planning stage is just really to communicate it. And I think USGBC does a great job of this, and some of, a lot of our projects do a great job, but it's really just enforcing that everybody needs to be on board. We need all hands on deck, and that everyone who partakes in the project is a part of this. So drywallers, electricians, plumbers, mechanicals, the GC, everyone's work affects how successful the end result will be. So we want to make sure that they've got the whole team has the resources, they know what's expected, and if they have any questions that the architect can clarify or the GC can clarify. Next step, building it. So now we're into it. So next step, starting off at the bottom. As I mentioned earlier, some of the transition areas are really important to take a look at. So here I've got two slides. One on the left side is a crawl space. The one on the right is a foundation basement wall. One of the, an important area to look at is above the foundation wall where the bottom sill plate is, that you put a gasket underneath there and seal along, because you'll get air leakage through that area. Your band joist, you can use foam, you can use a variety of different materials, but that is a key area of leakage that happens. Next slide. Above grade walls, we talked about it before. We do see a lot of zip panels coming up on the market. The one on the left is a zero energy ready home that we did in Oak Park. It was actually a prefab home, so the wall panels were brought in, which was kind of cool. And then the one on the left, and the one on the right is actually going for a Living Building Challenge, and it's still in process. But the one key detail that I would mention with this is with the zip panels and the taping, making sure that you've got a good stick on the seams. There tends to be some gaps at times, so they've got a roller tool that you can use to make sure that it's flat and tight, and that it covers all the areas. Next slide. Windows and doors, again, any break in the envelope, any intended break in the envelope, you want to make sure that you're using whatever proper material that you can use. So here we've got tape, we've got foams and caulks, but making sure that you've got the rough openings and the windows and doors sealed. Next. Mechanical penetrations, as I mentioned before, you can use a variety of different products, whichever ones work best for you. Some are more expensive, some work in better scenarios, some are just caulk. So the picture on the left was Zero Energy Ready Homes project, and they used the Sega tape, duck mastic, as well as caulk around the penetration to the outside. This is an exterior wall. So just really making sure that you're doubling down and thinking of sealing that up correctly. Next slide. Ceilings and attics, same thing. The slide on the left is another Zero Energy Ready home. They use the Intello Wrap, which is a pretty cool product, Sega tape, and then the one on the right is a Passive House project that was just recently certified. And this builder just did a really, really good job. Clean lines, making sure that they caulked everything, that they taped everything, and the certification went super smooth because they thought of everything up front. Next slide. And then the last piece is to test it. Next slide. Which we call our red door of truth. And we would recommend something that we do with all of our projects, but don't wait until the end and have your blower door test. So this is a blower door test or a blower door setup. It comes in all shapes and sizes. And I would hope that that your house doesn't need the 3-panel like we see Graham on the right. That was actually at a school that in the Chicagoland area. But we come there during mid-construction to test the envelope, and that's really what the blower door does. It tests the air barrier, it tests your air sealing, and we do the mid-construction test as a resource for the builders and the team so that we can find any areas of leakage at a point where we can fix them early, and so we don't wait till final testing. And then at final, we come in again if it's for a certification or if it's for code, and hopefully at that point all of the things have been addressed and we're smooth sailing. So next slide. And that's it. Happy to answer any questions that you have, but again, you can do this, and it's just a matter of planning ahead and making sure that everyone's on board. And with that, I will hand it off to Mike, who will talk us about how to get some space conditioning in our super tight homes. Mike?
Thank you so much, Lindsay. And thank you everyone for attending and for allowing me on this panel to actually speak to air source heat pumps and how we can actually heat and cool these all electric homes. When I was putting some slides together for this presentation, I was thinking to myself, there's so much that can really go into how you actually effectively and efficiently heat and cool, not only an all electric home, but any home in general. So I tried to pare this down to 3 general rules and concepts that I try to live by and implement when speaking to builders or architects or contractors, especially when they're looking at doing their first all-electric home. And how am I going to heat and cool this actual space? What, from a simplistic standpoint, do I need to look at as a primary focus? And then we can deal with the other details as we get a little more used to doing them. So how do you heat and cool an all-electric home? Luckily, you saw a lot of things that we're going to speak to already in some of the other slides. You saw a lot of equipment in Kellen's slides, which was great. We're going to take a look again. And my number 1 rule is tighten up the envelope, which Lindsay just spoke to. So I'm done. I guess I can turn mine off now. Thank you for that, because everything that she mentioned is exactly what we need to do when we're talking about heating and cooling an all-electric home. It's tighten up that envelope. The lower the heating and cooling load that the home requires, the less energy, in this case, electricity, the HVAC system will use. So how do you lower the heating and cooling load in a home? There's one of 2 ways. You either shrink down the size, right? Less square feet is going to take less of a heating and cooling load, or you tighten up the envelope. So tighten up the envelope is pivotal when we're looking at an all-electric home, because we want to use the least amount of energy possible to heat and cool that space. So the lower load in the home equates to a smaller HVAC system. So if we lower down that heating and cooling load, we can shrink down the size of our HVAC system, thus resulting in less energy, electricity being used to heat and cool the home. So that's number 1. Anytime we're talking about an all-electric new construction home, we need to focus on the envelope first, number 1. Rule number 2 is not all electric HVAC systems are created equal. So I'm specifically talking about air source heat pumps, air source or ground source heat pumps only. If we start to get in the conversation, what do I go with, air source or ground source? There are a ton of different characteristics and things that could come into play and exactly what system that you would want to go with. In this case, we're speaking about air source. Ground source has its place too, especially if there is land available to use, but we definitely want to stick with the heat pump, air source or ground source heat pump. And when I say only stick with the heat pump, you're thinking maybe what other type of way would I heat and cool an all electric home? I'm not doing it with a gas furnace. There's also electric resistance heat. We definitely do not want to look at utilizing electric resistance heat as the sole or primary source of heat for an all electric home. It just costs too much to operate that. It's okay as a backup, which we'll speak to, but we want to make sure we're sticking with a heat pump always. Inverter-driven compressors make all the difference. Not only are not all electric HVAC systems not created equal, not all heat pumps are created equal. So we want to make sure we're working with a system that has an inverter-driven compressor. So what in the world, oh, my little click isn't working. That's okay, I'll speak to it. I had some embedded slides that were working on practice and now they're not. That's okay, no need, I can speak to it. So what is an inverter-driven compressor? An inverter-driven compressor, in the simplest concept, is like cruise control for your car. We talk about a traditional air conditioner in your home, which most people on this webinar are probably going to have. That is most likely a single stage compressor, a 1-stage compressor. So what that means is when your home is calling for air conditioning, that compressor, which is sitting outside in your air conditioner unit, it's the heart of the system, is going to turn on at 1 speed, 1 capacity, and give you everything it's got. And then what happens is that compressor runs at that full speed, 100% capacity until that temperature is reached in the space, and then it turns off. And then it waits for the call for cooling again, and it cranks back on. That's where you can see dimming lights in your house. That's where the big energy draw is on a heat pump or an air conditioner. It's at startup. So what an inverter compressor does is it actually starts up fast to drop that space temperature, or in heating, raise that space temperature. And then it in turn hits the space temperature and then just modulates down. So it goes where you want to go, gives you as much heating or cooling as you need, and then it just cruises to maintain. Think of it as highway miles in your car versus city miles in your car. A single stage compressor is start and stop, and an inverter driven compressor is cruise control. So it makes up big in efficiency gains as well as comfort gain for the home. Because while we want to be efficient, we got to be comfortable too, or nobody's going to want to build that all electric house. So inverter driven compressors are a must. Lastly, here under rule number 2 is cold climate air source heat pump systems are a must. Backup heating systems are a good safety measure for emergency circumstances. So what is a cold climate air source heat pump? This is where I would have shown you a couple pictures, but that's okay. A cold climate air source heat pump is a heat pump system that actually can produce efficient and effective heating down into the deep negative temperatures that we experience here in Chicagoland. There are standard air source heat pumps that still have inverter driven compressors, but they can't produce heating effectively and efficiently in colder temperatures. Those heat pumps are great for supplemental heating. Think of a home that already has a heating source, or in warmer climates where you don't need a cold climate heat pump. Regular heat pumps are great, but when we're talking about heating an all electric home here in Chicagoland, we need a cold climate air source heat pump. So we need something that is going to be able to maintain its heating capacity all the way down to the deep negative temperatures. Of course, I can speak to our systems here at Mitsubishi Electric, and we have cold climate air source heat pumps that maintain 100% of their heating capacity all the way down to -5 degrees now. So that means you do not start losing any of your heating capability until you're hitting -5 degrees. And that's ambient air temperature, not wind chill. We're only worried about ambient air temperature. And we know it gets cold here in the winter, but ambient air temperatures don't usually get into the deep negative temperatures. So while we're 100% capacity at -5, we're still maintaining on average about 82% capacity all the way down to -13 as well too, with operation beyond that. So cold climate air source heat pumps are an absolute must when we're talking about heating these all electric homes. I mentioned before we want to stay away from electric resistance heating. We do, as a primary main source of heat. It is okay to implement some electric resistance heating for backup measures, for emergency circumstances, for where maybe my heat pump loses operation for whatever reason it might be, act of God catastrophe or whatever that might happen, that I do have an emergency backup. Or if my heating load is big enough that I'm losing capacity and it's -20 degrees outside, I could have some backup electric resistance to supplement just for a short period of time. That's where we want to implement some backup heating sources. It's a good safety measure. It's not a must, but it's a good safety measure. Rule number 3, the HVAC design is crucial. So thank goodness that Kellen had some great pictures of the projects that we worked on here in Chicago for that pilot program, because this is where I was going to show some other pictures on here, but these links are working with okay. Actually, this one looks like it is. All right, the other slide wasn't, but this one is. So what type of indoor unit styles can you see? There's a lot of them out there. Horizontal ducted, that is a small, slim ducted unit. Maybe I want to I have a space or multiple spaces that need short amount of controlled and sealed ductwork. Horizontal, small footprint style ducted systems are great. We saw some pictures of those on Kellen's slides as well. How about a ceiling recessed unit? What if I'm going to go ductless and not have any duct work at all? You saw a wall mount on some of Kellen's slides. Here is a ceiling recess system. So this is taking a ductless indoor unit and actually putting it up into the ceiling in that space. So it gets it off the wall and you can implement that into the ceiling. It's another option. There is also floor mounted units or low wall mounted. We deal with a lot of attic conversions and bungalow style homes here in Chicago, where you have a second floor that doesn't have a lot of high wall space. A low wall unit is another option. Get that off the high wall. Or then you have your traditional high wall mounted units, like you can see here in this picture, or here in my fake living room behind me that I have. There's a wall mount unit. Those are the most traditional, most common style of ductless systems that we'll have. And then you saw pictures on Kellen's slides as well of multi-position air handlers. So if we want a really true traditional style look and feel to an all-electric home with a heat pump, multi-position air handlers. The homeowner knows no difference that this is a heat pump versus a traditional furnace and air conditioner that they may be used to, because from an aesthetic standpoint, it's identically the same for what they've seen and been used to all these years. You saw all those different styles. So ducted, ductless, or mixed, what's your best choice? Kellen mentioned that a lot of those projects were a mix of ducted and ductless indoor units. That is a really great solution to an all-electric home. I am not anti-ductwork, even though we're considered a ductless company, as you can see with the ducted options we have, but it's all about controlling it effectively. So Lindsey mentioned about sealing up the envelope. That's also sealing up the ductwork and testing the ductwork effectively, so that if we are using that, we're keeping all of that conditioned air in the conditioned space, right, within the envelope. So seal up that envelope, seal up that ductwork, and keep that ductwork in the conditioned space. That way we're not losing anything. We're putting all of our heating and cooling into our space. So a mix is a really good option. Ductless only as well, depending on the application. Maybe it's an ADU application, so an accessory dwelling unit. We're doing a lot of those now that are small, and a ductless unit by itself would work just great. Or a ducted system. A fully ducted system is going to be your most traditional. That's where I fall here. A fully ducted, cold climate air source heat pump system with backup electric heat is a fantastic starting point for all electric new construction homes. If you have any doubts, if you're not comfortable about ductless, or if the homeowner is going to want to have ductless, a very traditional approach of a single stage or of a single zone or a multi-zone, fully ducted cold climate air source heat pump, a full multi-position air handler is going to be a great starting point for your all-electric new construction homes. I just saw this chat pop up, says, how do you handle air filtration in the ductless systems? That's a really good point. I'm just going to handle it real quick before I move on. With a ductless system, we're filtering the air of the space that we're actually in. So if I'm taking my fake living room here, my ductless wall mount unit is filtering this room and this room only, which is really good. It's not going to be a super high MERV rated filter because it's a ductless, and it can't. You just can't put a MERV 13 filter on a ductless system. It doesn't work, but it's filtering the air within that space. We want to tie in ventilation as well. So ventilation and fresh air is where we're going to get a lot of air filtration. Does that mean tying in an ERV? Does that mean tying in other different types of ventilation systems? That's what we want to look at. All these projects that Kellen showed that were in this pilot program have energy recovery ventilators, fresh air ventilation of some sort that's helping with that air filtration. Go for it. That's the last thing I want to say. Don't be scared of all electric new construction, and don't let the HVAC portion scare you away either. Cold climate air source heat pumps work. They've worked for a long time. Obviously, you can see all these projects have them in there. We can do it from a very traditional standpoint, or we can get a little creative. That's what I'm here to help with. This is my contact information. I'm local to Chicagoland. Please reach out if you have any questions related to anything regarding the mechanicals, the HVAC for an all-electric home, or a retrofit, or multifamily, or anything related to that. I'm here to help. We have some great resources that we work with, like everyone on this panel here and everyone in the industry. We have great contractor recommendations we can make as well. So you're not going to be entering into this alone. Don't be afraid. Please lean on me. I'll help you out in any way that I possibly can. So thank you very much for my time, for your time on this panel here. I wish some of my slides worked, but that's okay. No big deal. We're going to lean in now to Lisa from Albrecht Solar, who's going to talk about integrating solar into these all-electric new construction. Thank you, everybody.
sorry about that. I dropped my mouse and it exploded. So little tech issue. Hopefully you can hear me. So it looks like we've got, we're trying to aim for about 12:50 so that we can handle Q&A. So I'm gonna cruise through these really quickly, but I would agree completely with what Kellen, Lindsey, and Mike all mentioned, that starting with an envelope and a really efficient home is going to always be first. And then you can look at electrification for owning your own power and creating that energy on site. I always like to talk about the Illinois Solar Energy Association. I've been with the organization since 2007, but we've had presence here in Illinois since 1975. So although people think that solar is new, it's not new, and it's also not new to Illinois. So the organization's been around for a long time. I'll talk about a few things. I like to always just touch lightly on solar myths. There's a lot of misinformation regarding solar. Knowing there's a lot of contractors on the line, I'd also dive into Solar 101, and then what are the steps for going solar. I apologize, I'm having a rough asthma day today. So there's a number of misinformation out there regarding solar. I think a lot of these myths are starting to get debunked on a regular basis, but we still hear them on a regular basis. So starting with, it's too shady. This map shows you the irradiance around the United States. Of interest, you know, until recently, Germany led the world in solar power. China is now #1, but Germany has about the same amount of sunshine as Alaska. So if that good German logical brain says that solar is great, then you can see here, you know, looking at the scale at the bottom showing the availability of sunshine, we're not that far off of Miami or even Atlanta, Georgia. So we do just fine. Of course, last week was awful. The last couple of weeks have been terrible. When solar panels are covered in snow, they're not going to work, but we're really aiming for, you know, our primary production in the summertime. In particular too, solar panels are cooler here than they are in some of the warmer states. And so we have got a lot of efficiencies that are going to help the system generation. Next, we hear that solar is too expensive. It's shocking how far solar has come down. When I first started in the industry in 2007, pricing was around $13 a watt. This week I'm pricing systems for $3. So pricing has come down tremendously. In addition to that, there's some wonderful incentives. The federal tax credit is set at 26%. It was supposed to slide to 22 this year, but fortunately, Washington, D.C. woke up and got some work done in December. There's also, for businesses, you're able to take accelerated depreciation. For this, on the state side, we have what's called the State Renewable Energy Credit Program. And I will dive into some details about that, but you can essentially think of that as a carbon offset. So a lot of good things. Between the two of them, you're looking at between 50 to 60% savings from the total install price. There's also a program called Solar for All for low income. It's a little bit more complex. I won't go into that today. The renewable energy credit, again, as I mentioned, you can consider it kind of a carbon offset. In this case, system owners are not selling the electrons. That's through a program called net metering, where they're making their own power, but any extra generation goes back to the grid. What a carbon offset is, or a renewable energy credit, is the clean attribute. So the fact that a solar producer is making clean energy means that the utility does not need to buy that power off the grid from dirty resources. So here in Illinois, we have a goal of 25% by 2025. We're at roughly around 8%. Unfortunately, the program is currently unfunded, and we do have several pieces of legislation in Springfield, including a program called Path to 100, as well as the Clean Energy Jobs Act. So there's a lot of great attention that's being paid to reinstating this program and getting it up and running. The problem with the program is that solar has been wildly successful. So we spent the money. We thought we would have a clean runway for funding through 2024. These are ratepayer dollars, not taxpayer dollars. And we ran out of funding in December of 2020. So it's been a very successful program. And we're looking to get something passed, you know, hopefully no later than May 31st, which is the last day of legislation in Illinois. So I'm happy to talk about that a little bit. So just a couple of myths out of the way. Solar 101, there's two really types of technology. Solar thermal was very, very popular, 70s, 80s, 90s, even into the aughts. We haven't seen as much of that in the area recently. It's my favorite system because it is 70% efficient, 7-0. But it's a little bit more difficult for incentive programs. Primary copper components are copper, steel, aluminum and glass, so there's not a lot of savings that we have seen on the photovoltaic side. PV is the more traditional form of when people think of solar energy, they think of the production of electricity. Here's just a really quick image. So essentially inside of a solar hot water collector, we're collecting the heat of the sun, using that directly as the form of heat to then tie into either water heating or home heating systems. Again, there's not a lot happening in this market segment currently, but certainly we hope to see a resurrection of this technology since it's so incredibly efficient. On the photovoltaic side, Katie, could you advance? For some reason, this is not moving for me. There we go. Thank you so much. On the photovoltaic side, it's very simple. It's a passive system. As sunlight reaches the surface of the collectors, it excites the electrons. That creates DC current. We bring that power down into the home through an inverter. It makes a simple conversion over to AC, where we're either tied directly into an electric panel, or we can tie into the meter, into what's called a load side, or sorry, a line side connection. Any loads that are calling for energy will come first from the solar, second from the grid. If you're making more power than you need, it bumps back out to the grid where you're credited through net metering programs. So it's great as we're seeing the advancement of electric vehicles and the electrification of our transportation system, the electrification of homes. Solar is a really great, efficient way of producing the energy right on source where it's needed. Just a quick picture, there's just a couple pictures. Typically panels are installed flush to the roof with about a 6-inch gap between the panels and the roof. Nice thing about that is it kind of creates a thermal barrier, which keeps your attics a little bit cooler, but also that gap will help keep some circulation to keep the modules cool. All electronics like to operate at cooler temperatures. Just a couple pictures. Inverters can either go inside the home or outside the home. They are NEMA rated for outdoor conditions. There are some disconnects also required by the utilities in some municipalities, although ComEd has now decided that they are not required. Some municipal codes have not quite caught up with that recommendation. Again, we can either connect through the electric panel, which is a breaker fed system, or we can also connect to, on the supply side, in a meter pedestal if there is some space in that pedestal. We can also put some monitoring devices on so that you can read not only how much the solar is producing, but also how much you're drawing in from the grid. So you have some interesting consumption data on top of your solar information. Everything for solar energy has online monitoring. So we're putting a silent device on your roof. So it's great to be able to see that your system is working, but also to see how much power you're producing. It's really exciting to see year over year, day over day. Again, numbers weren't great last week, but we're really looking at very short days in the winter. And so for the $10, $15, $20 that people lose in a month when we've got rough weather, it's not something to worry about. But it is really fun to go out and look at, this is a pretty good weather day when you're looking at that production curve from your online monitoring. You can even see it from your phone. On a flat roof, or sorry, on a pitched roof, you want to make sure that you are properly flashing your penetrations and making sure that the house is protected from any water issues. Most systems are rails and they typically will run perpendicular parallel with the plane of the roof. And you can see here we've got some micro inverters or some optimizers on the roof that allow you to get some panel by panel performance. That is now standard and required for rapid shutdown. Attached on flat roofs, we can sometimes go with attached or fully ballasted system where we're using the weight of the array and some additional loads to hold the system done, or possibly a hybrid where we're using attachments and weight. Steps for going solar, really the main thing is do your homework. You really want to see how much sun is available. There's a lot of resources for that. The ComEd website has some things. This is an example from Google Project Sunroof. If satellite cannot see your house, neither can the sun. This is a really good place to start. There are a lot of numbers in there regarding production information, pricing. These are taken from national averages. You're going to really want to rely on a solar developer to understand those in greater detail, but it is a good place to at least start. You want to look at the building, how many roof, how much ventilation is sticking out of the roof, are there bathroom vents, things like that. I do see a quick question about cedar shingle. That is a very tricky process, and sometimes what we'll do is we will avoid the areas with the shingles And so, you know, we're playing a large game of Tetris on the roof with a large rectangle, trying to fit it into different spaces. Next thing is look at your electric bill. A little bit harder for new construction. So you want to work with energy raters to be able to come up with some forecasts, but really understanding how much energy you need to offset. The nice thing about a tight envelope is that you're going to be using a lot less power. And so really kind of looking to understand what your energy needs are. Just some rough budgets, roughly speaking, a PV system is somewhere at around $3 a watt, between a 5 kilowatt and 8 kilowatt system before incentives. Of course, permitting needs to be considered. Structural, typically speaking, solar is only going to add about 3 pounds per square foot, 7 pounds at the absolute heaviest. These numbers are a little bit more detailed to go into than we have right now, but this will all be provided. And you can see how I walk through the 20% federal tax credit, the price for the renewable energy credit program. For homeowners, that's paid in year one. For commercial projects, it's split over a 4-year period. So you can see some of the metrics and the numbers. This is a little bit of a longer payback period. I am seeing a lot of projects somewhere in the 8 to 10 year payback period. It really just depends on the project and some of the complexities. Once you've done your homework, finding a contractor, like anything, making sure that you've got qualified professionals that are doing the work, understanding how you want to pay for the system. With low interest rates right now, many people are wrapping it into either the original mortgage, which is a fantastic way of looking at it, or if it's a retrofit, refinancing the home and adding solar. You can also do what's called a power purchase agreement. There's a lot of ways that people can get things done. All solar projects are going to require a separate permit specifically for the materials. All totaled, it's going to take somewhere between 2 to 6 months. The actual installation is very, very quick. This is just an example of net metering where you see the credits coming back on your bill. And that was it. If you can, one of the best ways to support the Illinois Solar Energy Association and make sure that we have good legislation this year, and those incentives are rolling again, is through supporting us with the Tesla raffle by going to go.rallyup.com, and you'll be able to purchase either 4 tickets for $300 or a ticket for $100. We're only selling 2,500 and we'll be pulling right after Earth Day. So that is that. I will pass the baton back.
Thanks, Lisa. So I think we have just a few minutes to go through some Q&A. So if everyone wants to turn, all the panelists want to turn their cameras back on. There were a lot of questions, and I know we won't be able to get through all of them, but we'll just see what we can get through in the next few minutes. Oh, sorry, my video isn't on yet. The first question I want to ask is for Lindsey. I thought this was a great question. Do you have any resources that you can share, or any way you can point people into the right direction for contractors looking to learn more about implementing tight sealing and sealing of envelopes?
So there's less actual sealing trainings. However, there is a passive house builder training that happens, which, you know, kind of takes you to the next level. I would say start off with, there could be small trainings that are provided by like NAHB or some of the local chapters. But from what we see, it's a lot of more get your resources online and look at some of those details. I unfortunately don't see a lot of air sealing trainings, which is really unfortunate, because as like the energy code is getting tighter and as we're looking to try to hit these targets, we need to be able to have people getting trained in order to do it. So I unfortunately don't have a specific source to go to, but I would say start with some of those like materials, and construction instruction has like videos, and look at Passive House and just keep up to date with some of your local home builders associations and things like that.
Sorry, I think my computer cut out for a second, but thank you, Lindsey. Next question. I saw a lot of questions come in asking, Mike, this is for you, just about their existing homes and wondering if some of the technologies and the heat pump water heaters that you talked about are a good fit for already existing homes versus new construction.
Yes, everything that I mentioned about and everything that you showed with heat pump water heaters as well, even though we're not heat pump water heaters, can all be implemented into existing homes. The key is heat pump technology in general. When I'm talking about air source heat pumps for space heating, not necessarily the cooling factor of it is it all depends on really that first rule that I talked about, which is tightness of the home. Because what I would never recommend someone to do, mainly because of equipment cost and size and scope that it would take, would be if you require 100,000 or 120,000 BTU gas furnace in your house, don't tear that out and just try to go all electric without addressing the envelope first. Because the key is to lower your heating and cooling load so that a heat pump becomes actually a recommended thing to do. At that time, I would never say just tear the furnace out and put a heat pump in its place and you're going to be good to go, because your heating output may not be enough. You may have to do multiple systems. So lowering that load first. However, implementing air source heat pumps into existing homes without addressing envelope for certain areas of a home is a fantastic thing to do. So say you're doing an addition, or you have a place in your home that just is not comfortable from being heated and cooled from your furnace in the house, you can add in a ductless air source heat pump system to handle that area too. Implementing heat pump water heaters is actually a lot easier from that aspect into existing home, because it's very similar. Very similar in size and similar in install. You just have to have there's air exchange that has to occur in a heat pump water heater for air intake as well as exhaust. So the location may not be ideal for it in your home, but if you have a mechanical room or something, it's definitely a feasible technology to put in to an existing home. Same with air source heat pumps. We just got to be careful. So it's address that envelope first if we're looking to take over the home with an air source heat pump.
Thanks, Mike. I'll try to squeeze one more question in, and then I know we need to wrap up. Lisa, there were a handful of questions about both the durability and longevity of having solar. So one question in specific about, hailstorms and just different weather, but also just the logistics of what happens when you need to replace your roof and you have solar on there. What do you do?
Yeah, no, great questions. So the modules have been, improving in durability. They are hail tested and rated for quite a bit of weight on top of them. So even in the heavy snow that we recently have, solar panels can handle the full dead load of that. They are warranted for 25 years. And so it's possible. That's why we always want to start with a good, clean, healthy roof, something that's, really not any older than 5 years, because if you do need to re-roof, you'll need to take your solar panels down and do the roofing work and then come back and put the modules back up. So it's always best to install first with the, with a roof that's under 5 years old. Did I answer both questions?
Yeah, thanks, Lisa. And I think that I see Katie popped on. So I think, unfortunately, that is all the time we have for questions. And I apologize for anyone who couldn't hear me. I'll hold my mic up for the last sentence that I'm saying. Thanks, everyone.
Thanks so much, Kellen. And thank you all for being amazing panelists today. We had over 200 people attending this webinar live. So we know this is a popular subject, and we'll definitely continue doing more on this topic in the future. Thank you again to the ComEd Energy Efficiency Program for partnering with us on this event. We're really excited to follow up with resources in a follow-up email as well. So you'll get the recording, you'll get a copy of the presentation to look a little bit more at the slides as a PDF. We'll send resources and links to the things we discussed today. And there were over 30 questions in the Q&A and the chat that I counted that I think all got answered, but we'll also make a document so everyone can see those questions and answers in case you missed it, and those would apply to you in the future. So we'll take a look at those and make sure we get everything to you in the next couple of days. Thanks everyone again, and have a wonderful afternoon.
Thank you.
Thank you.
Bye.
Thanks, everyone.